On this page of your notes, we're going to introduce you to some basic equipment that we're going to use often in this class and indicate what it is that you're going to be measuring. Many times you're going to be asked to take the mass of an object. So we could use a triple beam balance, which you see here, but that's kind of old school. And now we have these electronic scales that we can use to get mass. So these are used to measure mass. And oftentimes we're going to be measuring mass in grams. So if you see grams or kilograms, then you know that we're measuring the mass of something. Mass is different than weight. A lot of students will say take the weight whenever we're using a scale, but we're actually getting the mass. Here's a practice to do, and this is with the triple beam balance, where we're going to see what is the mass of this object that is on the triple beam balance. We have 3 different beams here, so we just need to basically add up the numbers. We have 400 plus 60 plus 6, and then you can see that we are 2 over from the 6. So that means that our mass would be 466.2 grams in this case. Obviously, with a thermometer, we're going to be measuring temperature. We can measure temperature in degrees Celsius or degrees Fahrenheit. In science, we more often are using degrees Celsius. So I want to give you some ideas of temperatures so that you can get more familiar with the Celsius scale, because most of the time we're operating with Fahrenheit scale here in the United States. You probably have heard that freezing is going to be 0 degrees in Celsius. 100 degrees Celsius is the boiling point of water. To give you some more reference though, room temperature is about 23 degrees Celsius. And body temperature, which is 98.6 in Fahrenheit, is about 37 degrees Celsius. On some problems, you're going to be asked to decide if a temperature using an experiment is reasonable. So you might need to keep these numbers in mind. If you're testing a living organism, you're going to see how temperature is affecting that living organism, then you wouldn't probably go much above 37 degrees Celsius. That's close to around 100 degrees Fahrenheit, because you know that you'll end up killing your organism. Now students are going to be asked to indicate temperature, such as you see over here. And you need to take your time, because this seems to be pretty easy, but I see a lot of simple mistakes. So take a second to see if you can indicate the temperature in degrees Fahrenheit and then also in degrees Celsius. If you want to pause to do this, go ahead and do so. The most common incorrect answer I'll see students put here is 71, because they see that the temperature is up to this first mark here. But you need to look at the increments. This is going to be 72, 4, 6, 8, 10. So the correct answer is 72 degrees Fahrenheit. When you go over here to the Celsius scale, then they're going up by 1. So it's going to be 22 degrees Celsius. Obviously, with a ruler, we're going to be measuring things like length, width, height. We can calculate volume, we can calculate area. Take a second to look at these 2 measurements I have over here for you to practice with. I have a red line here. I want you to measure the length of that red line. And then I have a fish here, and I want you to measure the length of the fish. Now we're going to operate in centimeters, meters, millimeters for the most part in science class. So if you can indicate what is the length of the red line in centimeters and in millimeters, what is the length of the fish in centimeters and millimeters. So take a second to pause and do so. Sometimes students get confused as to what are the centimeters on a ruler versus the millimeters. So let's indicate that from here to here is going to be 1 centimeter. And then these little marks up here are the millimeters. So the red line is 123.2 centimeters long. And if you count the hash marks, there's 10 hash marks, 10 millimeters and a centimeter. So we have 32 millimeters. For the fish, they made a mistake by not putting the fish at the 0 mark. And so some people don't catch on to that. So the fish isn't going to be 9.2 centimeters long. It's actually going to be 8.2 centimeters long. Again, you can count the millimeters or just note that there's 10 millimeters in 1 centimeter, so that's going to be 82 millimeters. Next, we're going to look at measuring volume. When we're measuring volume, we often are using things like liters or milliliters to indicate the units here. We can also use a pipette to measure out a milliliter, usually small amounts like 1, 2, or 3. We can also use items like graduated cylinders. They're going to be tall and skinny, versus a beaker is usually more round, flat. So take a second to go look at this example and see if you can measure the volume of this liquid, and this is going to be in milliliters. You probably already know that when you put liquid in a tall glass cylinder, you're going to see this curve here. That curve is called a meniscus. So when you go to measure the volume of that liquid, then you need to read at the bottom of the meniscus. So take a second to look at what are those increments that this is counting that by. So it's counting that by ones. So this is going to end up with 73 as its volume.